do you know what? It's now facing backwards. So because of my fancy little holder, it's filming the back of the phone. Okay, pause for a minute, people on the other end. We will get there. So, isn't it funny? Because we're not digitally minded people necessarily on this side. Okay, so bear with us. And how's that looking?
That looks fabulous.
Okay.
Looking good, Beck.
Kia ora and welcome to our maths evening. We may have people come in and go. As I said to you, the beauty of coming face to face is you get to korero and ask questions with us. Kia ora, I'm Beck, and we've also got Michelle who's holding balloons. So for those people who aren't in the room, you will not see what's on the tables, but on the tables we've got whiteboards and we've got erasers and pens, Cuisenaire rods, and we've got balloons. So this is kind of partially interactive to begin with, because we know maths is best learned through doing initially and all of those bits and pieces. So our strategic plan has four really clear goals. So when we look at it, we're all about collaboration, so that's us working with you guys, it's whānau with our community and all of those bits and pieces, and creating that community culture. Now we do that through different ways, through the streaming, through face-to-face, just being ourselves on that day-to-day, so, and also through assessment capable learners and learning and that focus on learning. And at the end of the day, we just want your kids to thrive, we want them to do well and succeed. So, I'm going to put Michelle in the hot seat now.
Right. Time for a little fun. If you could watch me with the balloon first, I'm going to teach you how to round to the nearest 10. So if I'm holding my balloon with my 5 fingers, if I'm going to have 52, and I'm going to take off 2 fingers, 1, 2, am I still holding my helium balloon? Yes, so it has to stay down to 50. But if I have 58 and I hold my helium balloon, and I take off 8 fingers, 1, 2, 3, 4, 5, up goes the helium balloon, 6, 7, 8, I have to round up. So get your balloon from your chair and let's do one together. Holding your balloon with all 5 fingers. So rounding up to the nearest 10. Right, let's try that again. Let's do from 76. Go. 6 fingers off. 1, 2, 3, 4, 5, 6. What happens to your helium balloon? It goes up.
and away.
So we have to round up. Right, try one more. One rounding from 91. Take 1 finger off. We've still got the balloon, so it goes to 90, it rounds down. You're holding the balloon, it didn't go up. Right, brilliant.
You can take those balloons home tonight. Okay? And one of the perks of coming tonight.
So that's about knowing the facts of rounding up or rounding down to the nearest 10. And we've done the do, we've actually got the balloon, we've practiced it, and we've now, with knowing and the do, we now have got the understand. We're understanding the concept of rounding up or down to the nearest 10.
So we're going to unpack that importance of concrete materials as well, alongside what we would call pictorial and abstract tonight too.
So this slide shows you some what we call engagement norms, just some examples of them, and we use these with the children, so we'll be using these tonight. This one here is peer and share, so you're going to talk to the person next to you. This one here, for example, is using the whiteboards. We've got the whiteboards on the table, so you might see those up in the corner of the slides tonight.
And these are all things that your children are being exposed to in classes from 5 years old to 11 years old, year 0 to year 6.
Right, so let's get our whiteboards. Can we get, can you get your whiteboard, and can you put your caps on? So put your caps on the end of it. And on your board, I would like you to write your name. Go. When you've done that, you're going to hover it, so turn it upside down, And you're going to go hover, 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 hover. And when I say chin it, you're going to put under your chin and go. Chin it.
The challenge is getting
Up
it up
the
the right way.
Flip. Right, catch fine. Right, bin it. So
we're going to use the whiteboards with you, and so as we mentioned, this is interactive, so those at home could have a bit of paper or bits and pieces as we're working. But the whiteboards are used throughout the school for different reasons in literacy as well as maths, and it's a great way for us to check for understanding.
So I could see instantly that all of you were engaged, that's why it's engagement, and you were all writing your name. I could see who was taking their time writing it. And then up there I could see everybody's board. Right, here's a bit of fun. So up the top we've got our engagement norms. You're going to turn to the person next to you and have a conversation about this. Is this picture accurate mathematically? Now I'll give you a little bit of a hint. The Cuisenaire rods are in front of you, and each of those Cuisenaire rods is worth a value. For example, the littlest one is worth 1.
Now the Cuisenaire rods have been around since the 70s, I think even longer than that possibly, so they are something that's been around for a while. So,
So you can have a look at that. If you look at the bottom,
so when we do that,
then if you look at the top, if you have the blue with the green on top, is that just the same amount as the yellow and white? So you want
It looks like it, doesn't it? But the left is
okay, we'll just give you another few seconds to have a look at that. So this is called a discuss and defend, where you actually have to discuss it and defend it with your buddy. So just give me a thumb up, because the audience knows that, or the part of people will face-to-face know they don't have to be loud and proud here today. Thumb up, do you think it's mathematically correct, or thumb down? Okay, so we've got a thumb down. Now, so often maths is, and we think as parents, what can we do at home? How can we help at home? Maths is everywhere. This was actually an art display at Te Papa. It's an art piece. Now, as a teacher, I walked up to it and went, oh my gosh, it's Cuisenaire rods. And the hilarious thing was there was another teacher just by me going, oh my gosh, it's Cuisenaire rods. No one else, unless you're a teacher or a child who thinks in Cuisenaire rods, would potentially see it that way. This was an art piece. So maths is everywhere. Maths is in the windows in this room. We've got 90-degree angles. So that's the beauty of math. It appears everywhere, and I guess as parents it's up to us to help show our children where it is and to identify it. Couple? Okay, so you've all had a chance to discuss and defend it, and some of you would have had memories of the Cuisenaire rods from your childhoods and all of those bits and pieces. And I've got some nods, so there's some nods. Very young audience. Okay, right. So the science of learning. Now we shared this same slide when we did our writing workshop as well, because it's relevant to everything. Cognitive load. For example, behind me you would not see, there's actually a shelf that would put a tablecloth over. Cognitively loading, and for the people who are here, if we'd left this open, you would have been distracted by all of the things on the shelves. Cognitive load can be impacted by so many things. So what we want to do is prioritise learning and maximise learning opportunities. The whiteboards, the engagement norms help us to keep the pace, because we know that if there's a perky pace, we're less likely to become distracted. unregulated. So that pace is really important. So, right, but you're here to learn about maths, not about cognitive load theory. Okay, so what we would say is students progress different at different speeds and different rates. We're all different. I've got a good friend who was a maths co-lead with me for years, and to this day, if I ask her 3 times 3, she has a panic attack. But she is really good at maths, but she actually processes at different speeds. Now, we're all different in the way we think, okay, and the way we would approach. So a lack of fluency, though, in basic facts hinders a child's progress and their problem solving. So we've got to have some basic knowledge or basic facts. So tonight we're going to share with you some of the things that we believe are the basics that you can actually help support at home, so that then when we're dealing with fractional thinking and ratios and all of that, you've got a basis to build on. Okay, so this is where we go to our whiteboards again. If you're at home, you can use a bit of paper. In this slide, what we're going to say is you can choose. Now, you can choose to go above the line and answer the questions above the line. You can choose to go below the line and answer the questions below the line. This is where we get our differentiation. We're all doing this together, but Patrice, I know she's going to go below the line. She's got really great basic recall, whereas Claire, she's an above the line because she's just working on her times tables at the moment. She really needs to consolidate them. So go for it. Answer as many questions as you can. I'll give you a couple of minutes. Now, as the teacher, what I'm doing is roaming and keeping an eye on them. And I'm cycling out to anyone I need to. But I can see that we're whizzing through this now. They're choosing above the line or below the line. It doesn't matter how many questions the child actually does. And one of the things we know is that the quiet room is actually really important for that processing. So, if I was to continue to talk over the top of them, I'm messing with their cognitive load. Right, I'll pretend that I've given you maybe a minute or two longer, answer one more, and then go to hover, 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 and chin it. And very quickly, I'm going to do an assessment of actually where are you at with your maths and all of those bits and pieces. And I might go, oh, Michelle, I'll catch up with you later. Okay? And sidle up to her a little bit more. So what you're going to do now, though, is you're going to mark them and you say the answers as we do them. Of course, I'm not going to make the audience here do that with us, but the children, we would literally, like in a rote learning situation, say 10 times 4 is 40. 4 times 3 is 12. So even if I've chosen below the line, I'm still practicing these facts. I'm still reinforcing them. 8 times 3, 18. And so you've got the idea of what I'm doing, so I'll just whiz through. But for those children who have opted to go below the line, to go above the line, they're actually going to see the answers as well. So they are learning for that aspect. So that we would all say, even if you haven't done it, 20 times 40 is 800. So you're being exposed to that higher level of curriculum. 29 times 2 is 58, and so forth. We've got this. Oh, so that's a really good teaching strategy. When we put the stakes up there, it's really valuable and really common that the teacher does it. So, and actually we did a webinar the other day where they were talking about that being a good teaching point, because then kids are having to think more. So nice. Well done. Okay. I always make one mistake. Okay, so bin that, and we're actually going to park your pen for a minute. So often as parents, we're like, well, where's my child at? How are they going? All of those bits and pieces we wonder. So what it can come down to is often, yes, they, like my friend who I said doesn't know her 3 times tables, but actually she can think with what she knows mathematically. She can problem solve. So we're not going to say hinder her and only progress to a certain point. So this is a quick assessment, and I want you to imagine you are a 5-year-old or a 6-year-old, and I want you to think, how would you answer this question? Okay. 5 plus 8 equals what? If you have 5 balls and get another 8 balls, how many balls would you have altogether? Write that on your whiteboards now. Go for it. And thinking like a 5 or 6-year-old, you might be getting your fingers. Or I might be actually drawing my balls, or I might be, actually I know that one. Because some 5 and 6-year-olds actually know that one. Okay, and of course we would go to hover, 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 and chin it.
Yes, mine.
Okay, and chin it. Now, what I'm going to say to you is that this is the most important part. It's not actually how you got your answer. So I'm not going to tell you the answer, but it's, did you count all of them? Okay, as a 5 or 6-year-old. Did you count on from 5? Did you go 6, 7, 8, 9? Okay, because developmentally that's telling us where you're at. And also, did you count on from 8? So did you know to reverse and put the big number first and then count on? Or do you know that actually 8 is 2 less than 10? So I'm going to go to 10 plus 3. Okay, and it also, for some children it's just a known fact. So that in itself tells you how your child is developing. If you see it as a continuum of where they're at in that thinking. So fit it? Okay, we're now getting into year 3 to 6, and you might be thinking, gosh, the same question for all those year groups, because we know that it's a pipeline or a pathway of progression. So you'll be expecting at year 3 a level of thinking to year 6. Okay, and these are questions that have been asked nationally and internationally by one of our professional development providers that we're working with, and they're collecting data and trends around the world in the States, Australia, South Africa, and here. So our next question is 63, take away 36. How would you solve this subtraction? And I want you to show your thinking on your whiteboards. How would you actually solve that? And you can think like you're 31 or 23, whatever age group you want to go for now. Once you've got that, go to a hover. So we always say to the kids, flip it over, go to that hover, hover, hover. Okay, and then let's go to that chin it. Okay, awesome. And do you know what? It's quite interesting to look at all the different strategies. Now the beauty of this is you can't actually see each other's. So therefore, if, say for example, Michelle is facing the front and she's got it wrong, no one other than Michelle will know. So therefore her self-esteem maintains where it is. Okay, so this comes down to the strategies once again. So we've got correct column subtraction. That's our algorithm. A lot of you used the algorithm, which is the vertical algorithm that a lot of us grew up using, where we get the line and we use the plus or the minus. Okay, the correct place value, and place value is going 63, take away 30, take away 3, take away 3. Okay, and then correct compensation, I might go 63, take away 40, and then add the 4 on, so that's a rounding strategy. Okay, or I might have gone correct evidence of counting and telling marks and fingers. Now we would hope that D is not where your child in year 6 is thinking. That's not their go-to strategy, because in maths we want to be efficient and effective. Okay? And of course incorrect. Now, the trends across what the data is showing is quite interesting. You would assume by year 7 and 8, which is the same question, that all children could answer this. No. So, a lot of it comes down to, and Michelle will go into this, I'm going to try and not make people car sick with what I'm about to do and drop the phone. So, and if you can't see the table here, we're going to stand up. And what I've got is on this table is the concrete representations of these types of questions. So we've talked about Numicon before. So we've got a vertical algorithm that you can do Numicon with, and we can show that with the blocks. We have also got the likes of another vertical algorithm with subtraction. Does everyone remember the place value blocks? Okay, they are still around. They're still a fundamental activity or resource. Great for that compensation one, which I saw some of the faces going, 63 take away 40 plus 4. That is probably one of the more abstract strategies. And then our place value strategy, which is nice and easy to show with the Numicon shapes. So I'm just going to let those people who are here have a walk and have a look. Okay, but that's the beauty of the equipment. We need to be able to actually show and do it. So I've got a slide here, which is our place value strategy, which here we've got 37 plus 46, 30 plus 4, 40 plus 6, and so forth. We've got our place value strategy again, where we simply take away the hundreds, tens, and ones. So that's what we call place value. And I think back probably 5 or 6 years ago, kids were being taught like 20 strategies. Okay, lots and lots of strategies. And like they were going, well, which strategy do I use? Now, the main strategies that we are looking to use, there's one other called the bar model, which we're not going to show you today, are these strategies that I would recommend that your children have a really good understanding of by the time they finish primary school. Then we've got the compensation strategy. So this is where, which I call the rounding strategy, where we go in this one here, 30 plus 12 instead of 27 plus 15. So I've added on and added on. And also 299 take away 134 equals 165, and subtract 1, subtract 1. Okay, so these are great strategies. Anyone who wants the slides, we can totally flick them to you too. Then the vertical algorithm, you know, my bread and butter from my childhood, millions of these were completed. It's really reliant on your knowledge of being able to add in columns in your presentation. So I think there's been a big emphasis back onto the neatness of your handwriting and writing digits in boxes and all of those bits and pieces. So letter formation is really relevant. So Kapai, any questions about those 3 strategies so far? Okay, awesome. I'll let Michelle take over.
Hot seat. So if you have a look up here, this is the way that we learn. First we start with the concrete, so that's actually having things physically in our hands. Like we have the apples, we might have the Numicon pieces. And then we can move on to the pictorial, so we have to draw our thinking, so we'll draw the apples. We actually have to have the apples physically in our hands. And then you go more to the abstract, where you can just record it as like numbers and use symbols like addition and subtraction, division. And then as we get more experienced or older, with less experience like this, we have a lot of concrete. So in the year 1 classes, you'll see a lot of children having to have that equipment in front of them to be able to solve it. But they're still using pictorial, drawing pictures, and good and abstract. But further up the school in year 6, you'll have less concrete materials, but they're still there. It's still important that they have access to those materials. They have pictures, they can draw it, but it's a lot more abstract.
Now this is a continuum, because as you can imagine, when I'm learning to multiply and divide fractions with uncommon denominators, okay, I'm probably going to go back to using more concrete materials because I actually can't see that or understand the concept. So even at year 6, there's a lot of materials for new concepts and for new understanding, because I need to see it first to be able to, as we said, know it, do it, understand it.
And when they have it, they have those materials to learn the concept, but because they have that understanding of knowledge behind, they quickly move on to the abstract.
Okay, got set back. Okay, so you've heard us talk about do, know, do, understand. This is language from our curriculum, and it's going to go across science, PE, you name it, everything. It's going to be that 3 words you need to remember to understand what your kids are learning at school. Know, do, understand. Know, do, understand. So it's a rope that's interwoven, and that's basically the learning that matters. Okay? we all know that chances are we didn't learn to cook just from reading a cookbook. We actually had to do the doing and make a lot of mistakes, do a lot of burning and those bits and pieces. Another big thing that's come out of our maths curriculum when we talk about that specifically is there's been some quite large shifts in the expectations. So for example here, years 1 to 3, higher expectations. By the end of year 4, you're expected to, the old year 4 expectation is now where you should basically be for year 3. The times tables you needed to know when you were in year 5 and 6, you now need to know when you're in the middle school. So simple iterations like that are huge because actually as teachers we are now that perky pace and that repeat, rinse, review is really important because we need to ensure that very quickly what was not expected is caught up. Okay. So even, for example, decimals was a great one. It used to come in primarily introduced at year 6, just a little bit of place value, and then you'd add decimals when you were in year 7 and 8. Now you need to be working with decimals from year 4. Okay, and so fractional thinking. So we've kept that in mind, knowing that place value and decimals and what we call base 10 are really, really important, and we'll talk more about that. So this is an example. We used to have curriculum levels, we now have phases. So we're now phase 1 and phase 2 in primary school, whereas we used to be curriculum level 1, 2 and 3. So all of that sort of stuff I wouldn't worry too much about because we're going to tell you about, well, what does your child actually need to learn or what do they need to know to be able to meet that expectation. Okay. Once again, the understand is the big ideas. So the big ideas are the patterns and structures, the change and variation, the logic and reasoning. It's mātauranga Māori and mathematics. It's that continuous evolving human history of mathematics. Okay? Because we know maths has been around for a very, very long time and it's not going anywhere. Then we've also got the know, which is, as teachers, we refer to the strands. So that's your number, your algebra, your measurement, your space, your statistics and probability. And you'll often hear teachers referring to this curriculum as mathematics and statistics curriculum. It's not just mathematics. We know in a lot of our jobs now, statistics has a lot to do with everything that we do, so that real importance. And then finally, that knowledge is great, and if you can't do anything with it, you're kind of not in a place where you necessarily will have success. I might know my times tables on a good day, but it doesn't mean I can put them together in a slide set when I present to people. All of those bits and pieces. So it's actually being the do and being able to do with what we think. So that investigating, representing, connecting, generalising and explaining and justifying. Those are the big parts of the do of maths. So today we've had you discuss and defend. So you were doing the explaining and justifying to your buddy. We've had you connecting to situations. I have made you connect with a piece of art from Te Papa. Okay, you're representing situations, showing us your knowledge on the whiteboards. So already we've pretty much covered a lot of the do in this session so far. So we've got a couple of learning examples to show you how kids are learning and around a couple of points of relevance that we think are pretty important at the moment. We've chosen to focus in on year 2 and year 6. What we're about to show you is pretty much transferable to any age and stage. It's of course variant based on numbers and all of those bits and pieces. So this first one in the year 2 context, we're going to look at understanding base 10. Who's ever heard of base 10 before? Okay, it's funny, up until this curriculum, I don't think I'd ever read it written in a document. So base 10 is about basically underpinning maths. It's place value. Have you all heard of place value? So we all know about the hundreds column, the tens column, the ones column, the tens. Base 10 is the foundation of place value. And it's essential for being able to think with addition, subtraction, multiplication, division. So if you haven't got that strong base 10 or that strong place value, having all those facts, when you get to the do, you kind of fall over. Now, just to make it a bit clearer, so that base 10 clearly defines the value of each digit on its position. So 345, the 3 is in the hundreds, the 4 is in the tens, the 5 is in the ones. It's telling us that position. Okay, so base 10 really just place value. Now, I don't want to think about the base 10 of my age, you know, and all of those bits and pieces, particularly if I'm rounding, because it's not looking so flashy at the moment. Okay, my balloon is definitely going up. Okay, so, in a lot of classes you will hear your kids talking about, oh, we might do a slide set, or they're working through slides on the TV in whole class situations, or in small group situations. So we're going to put you through that same sort of scenario, but this is like the speed dating version of it, okay? So we've got slides like this, for example, teach, I start with the number 12, I count forward in tens, what numbers come next, and this is where I'm teaching you, well, after 12, so I would say 12 and 10 more is
22.
Awesome. When counting on in tens from 12, the ones digit stays the same and the tens digit changes. So we're actually being really, really explicit about that sequence and about that roll. We're not just saying a little fluffy, oh, you just do that. We're giving them the exact reason for it, because remembering that this is the base 10. If they get this here, they're also going to understand 1/10. This could be 12 tenths or 12 hundredths. It could be anything along those lines. So as you can imagine, I'd click my clicker and next would come up 22 and then 32, and we would all skip counting our tens, but magically I made them all appear at once. So we would take the kids through that. Now this is where we get up to what's called we do. So we have the I do, teacher tells explicitly, the we do. Now you're all going to do this with me now. So what do you notice? Turn and talk. What do you notice? We've got 21, 31, 41. Describe the pattern, guys. Describe the pattern to the person next to you. Okay, and that's where I'm listening as the teacher and all of those bits and pieces. At no point am I going to say, Patrice, what's the answer? Because of the fact, actually, I've listened to you all and I can hear, and that's when, because we're doing this together, I don't need to polarise that Patrice is the best in the class at maths, you know. I
appreciate
it. So that's where I'm going to say, yes guys, you're right, 21, 31, 41, 51, 61. The one stays the same and the tens are going up each time. And that's where, of course, I've got these prompting statements to help me as a teacher. Now, this is great because if you've got a Year 2 child, that's that same vocab, that same language across our 4 classes. Okay. Now, this is called a hinge, and you know, a bit of a UK word there. What it means is that basically I'm going to pivot as a teacher if you guys don't get this at this point, okay? So I might have to hinge and pivot. So what number does not fit in this pattern? Now I want you to put this on your whiteboards. I'll read the numbers to you and go to hover, of course. 17, 27, 37, 47, 57, 75, 77, 87. What number? And chin it. Now, well done, it is 75. Give it a tick if you've got it right. Correct it if you've got it wrong. It's 75. So if I've noticed that all of you have put in 37, I'm going to go back. And I'm going to explicitly do some more teaching around that concept, so that's why it's called a hinge. So teachers use different vocabulary currently. But that's really important. Even though I'm whole class teaching, I'm still responding to the need of what is needed in that moment. Okay, then this is where you do, and I'm not helping you because you guys have been doing so well. We're going to use our turn and talk here. We've got that engagement norm. I've counted, true or false, I've counted back in tens correctly. Okay, explain your thinking, turn and talk, 99, 89, 79, 70, 60, 50, 40. Have a chat with your person. What do you think? Use those prompters with your buddy. So all of those bits and pieces. Okay, and coming back to be 5, 4, 3, 2, 1. Those are all the strategies that we'd use with our kids to tie in there. And that's where we would go, okay, I might say, okay, Michelle, because I know Michelle's got this. I was listening to her talking to her buddy, so I know she's got this. I know that she's going to have success in this moment. Michelle, okay, can you tell us what you think?
I think that it is false because the ones needs to stay the same and it's changed from a 9 to a 0.
So I heard Michelle say that the ones need to stay the same and then the tens need to change as we go up in tens. Do you agree with Michelle? The meters? Absolutely. So we then bring that buy-in, even though Michelle has said her statement, I've rephrased it, you've got to then engage with us. So it's really quick pace. If you think about it, what we're trying to do is get you to engage at least 3 or 4 times a minute. Okay. And then, is this always true? Sometimes true or never true. We're going to vote for this one. When you count on or back in tens, starting from any number, the ones digit stays the same. True or false? Okay, so you're saying that I'm really checking for understanding here, and I'm going, yep, you've got this. So remember, this was a year 2 class. Okay, year 2 concept, but we know that if you understand that the ones digit stays the same when you add a 10 on, you can actually then do our place value strategy for when you go 26 plus 18 plus 32. Because you know that actually when I add the 26 to 10 to 30, my 6 is going to stay the same and my 10s will just increase. So that really underpins that strategy, as well as even when we're using our vertical algorithms and all those bits. Really important. Okay, key takeaways. I found the third one most interesting. I've never thought about it. So the base 10 number system uses digits from 0 to 9 and sometimes a decimal system. So if you think about it, place value applies to decimals as well, tenths, hundredths, thousandths, and so on. Base 10 digits gain value based on their position and can be multiplied by the powers of 10. Okay, so powers of 10 are really important. And then base 10 basically comes from the fact that we've got 10 fingers. Okay, we're humans and we've got 10 fingers if we were, given the 10 fingers. Okay, right. Base 10 knowledge assists with fractional thinking and decimal understanding too. So it's really important, particularly if you think about it, 9 tenths is equivalent to 0.9, which is equivalent to the same as 90%. And we all know we love a good sale. Okay, so percentages are so important right now in life. And particularly if you're a boy in a sports team, your score or your ratio of performance is pretty important. So that's that base 10 understanding of those things. Okay, so we're going to jump to a year 6 context. Okay, we've travelled on 4 years in our education. Okay, still building on that base 10 concept, and we're going to fly through this aspect. So, rounding. Michelle had our balloon activity, which was really lovely, and our helium balloons floated up, but unfortunately we're at a school and we couldn't afford helium balloons today. So, finding the approximate value of a number to a given level of accuracy. Often we will have an example and we will have a non-example. So we're explicitly saying how this is an example. 43 will be rounded down to 40. 216, if we're rounding to the 100, would be rounded to 200. That's below 50. Over here is our non-example. 40 is not rounded to 43. Okay, you would round to that 10 number if we're rounding to the 10. And 150 is not 15. 150 has 15 tens in it, but it is not rounding it to the nearest 10. So I'd be really specific in talking through those non-examples. Now, converting a number to a nearby number to make calculations easier. Now, rounding 6 to the nearest 10, okay? Michelle, we might hold the balloons for a minute, yeah. Don't know what I was thinking here. So this was our balloon activity. This was when our balloon flew up, okay? And here, 6 is not rounded because it's our non-example, but because it's saying don't round it. Okay, so we've got that. This is quite intentional. We've learnt yesterday that to have your slide set out with a column on the left and a column on the right, it's like a newspaper. Makes it easier to quickly read. A whole is all of the equal parts together, the entire object. This is the whole object. Okay, example, 4/4, a whole orange, 4/4, 4 pieces. Okay, this is a non-example of a whole. 2/4 is a half, and this is what a half looks like. So we're showing you what the example of a whole is and what the example of the non-example is. Okay, review. So review is really important. We know if we regularly review, there's something called the forgetting curve. If you basically don't touch on a piece of learning or information multiple times in a week, you will forget it. So, for example, when you say, but I told you on Wednesday you have soccer on Friday this week instead of, chances are, unless they were in the moment and that's their passion, they're going to forget that. So, that regular reminders, that whiteboard in the kitchen, all of those things that we do. So, we've got our place value here, tens, hundreds, tens, ones, tenths, hundreds, thousands, and our decimal point. So, we need to look at the place value. That's really important because our 3 strategies that we showed you are applicable to decimal addition, subtraction as well as to multiplication and division. All 3 strategies can be used if I've got, for example, 64 times 324, right, or 329. I can use all 3 of those strategies. One of them is smarter and faster. And as you get older, it's about thinking about which is the most effective strategy of those 3 to use. If I'm at the supermarket, I'm not going to get out my pad and do a vertical algorithm. So it's a context that do. So then I think the review, we can use a number line to help compare decimal numbers. And here we've got our decimal to the hundredths. Okay, and all of those bits and pieces. So, and we can round down and we can round up. So numbers are small, so we can use a number line to help compare decimal numbers. Numbers are smaller as we move to the left of the number line. Numbers are larger as we move to the right of the number line. We're explicitly telling your children that this is the reason why. A lot of you know that they respond to why really well at home, understanding that why. Okay, so our goal in our lesson, and remember I'm doing the speed dating version, we wouldn't quite go at this pace with your children. I'm condensing a 45-minute lesson into about 5 minutes so that you can see what they would go through. So we're going to round decimal numbers to the nearest whole number with a number line. Now, Michelle's going to bring back the balloon.
Oh, you want the balloon?
So we'll bring back the balloon. So here we go, Michelle, you jump on the seat for a minute. You might want to grab your balloon if you want to, but if you don't, you don't have to.
Okay, so you have your balloon and it's exactly the same and you can use it with fractions, decimals as well. So if you click on the next slide, so that's what we want to do in the next one. So which numbers round up to 1, down to 1 and up to 2? So if we take off 1 finger, 0.1, 2 fingers, 3 fingers, 4 fingers, still rounding down to 1. And take up next one, take off 5, the helium balloon flies away, and 6, and 7, and 8, and 9. Those are all rounding up. So exactly the same concept, rounding to tens could be used for decimals as well. And that's the balloon mass.
And that goes for even if you were going to round hundredths to tenths. Same applicable because it's the same rule. So if you understand it in numbers to 10, you actually understand it in numbers with hundreds in it. And when you're at the supermarket and it says $3.99, well actually I know that that's, if I've got cash, that's going to be $4. Okay, and all of those bits and pieces. I'm not sure if the supermarket rounded down though. That could be a conversation for later. And actually that's a good mathematical conversation. And the benefits of cash versus EFTPOS or credit card. So as you can see, Michelle's shown us that rounding principle, and are these the only ones we would break down with the children, but I'm still doing the I do. I explicitly teach to you. I explicitly tell you. Now, then we've got here more examples. We can round decimals with hundredths, and it's giving us that same model, that same principle to do the rounding. But as you saw, that basis of being able to round when you're 5 or 6 supports you when you're in year 6 or year 5 or 6 to be able to do what you need to do with different numbers. So rounding tenths, still round at 1.7 to the nearest whole. There we go, I'm here, so I'm going to round up to 2. Okay, you're picturing your balloon probably floating away if you're visual learners like me. And then I'm going to whiz through this so that you can see, and then we're going to now I'm going to do another one because I'm still teaching you, I'm telling you how to do this, I'm really scaffolding you. Round 4.5 to the nearest whole. Now we remember Michelle at this point, her helium balloon floated away. So is it 4 or 5? We know that it would be 5. Okay. Now this one here is my check for understanding, so we're going to go for whiteboards here. And I'm going to say to you, I want you to write the answer true or false. You might put a T or an F. Rounded to the nearest whole number is 2, and 1.4 rounded to the nearest whole number is false. Absolutely infinite. Alright, you always have a teacher who's too keen on. Kids like it when we're too keen on. Right, 1.4 rounded to the nearest whole number is 1. So I'm not leaving you to go, oh, I got it wrong, and not know what the answer is. I'm telling you what the answer is so you can correct it or those misconceptions. Okay. And then what we've got here is, this is my example where we all did that one together. We've all got this one. And now here, it's your turn on your whiteboard. I'm leaving my model here for you. So Claire can still reference this model and go, okay, I'm supported. Whereas Michelle's like, I don't even need to look at that left side. And she's going to do this one. So round 1.2 to the nearest whole number on your whiteboards. And hover and chin it. Absolutely. 1. Awesome. Then this one here is another whiteboard, rounding tenths. So there's lots and lots of practice, but you can see it's not me doing the practice, it's you doing the practice. And we'll just whiz through these ones, and you can imagine the kids just whizzing, rounding hundredths. So now we've done the tenths, so we're going to move to the hundredths, and we're going to explicitly learn how to round that. All of those, which is the closest whole to the 1.34. So imagine Michelle with 34 fingers. No. Well, in this case, we know that we're going to look at that place value column to the right, and we are going to, because that is our smallest value, and then we're going to round to that one first, and so on. Okay. And then we have our answer. So you can see there's lots and lots of really quick practice, and the whole time I'm checking for understanding. Now this isn't the way we teach all the time. Okay, I just want to make that clear. This is not the way we teach all the time. It is not the same in every classroom because the different mathematical concepts you have to teach in different ways. Today we're choosing to show you some number aspects so you can see the importance of place value, that base 10, the importance of having some facts to be able to think with, and the importance of having three key strategies under your belt to be able to think with. So if you think about it, I've got place value, I've got some basic facts, and I've got 3 strategies. I'm pretty much going to be good to go. Okay, and so once again, I'll flick through. Now you can imagine we've been through this whole lesson, and then we get up to what's called the independent practice, and now this is where I go, Michelle, hang out with me for a bit longer, okay? Claire, you guys all go off and do that independent practice. Michelle and I are going to do a bit more of the same to make sure that she's really got this consolidated. I'm not going to start going to Michelle 1 plus 1, what does that equal, and dumbing down the curriculum to her. So we have what's called high ceilings, low floor, and it's our job to support everyone so that they can attain. Okay. So I'm disappearing to go through that. Now, this is where I use Michelle, who's a wonderful assistant. And she's going to come around and hand out, because it's all good and well to know strategies, but everyone's children are at different age groups in this room. And some of you may have already had this from the Matariki evening, when you came through the room that was in here, or this is also on our website and can be accessed as well and downloaded. So, as a mum, to be honest with you, I've got a Year 5 student, and I love to say I'm good at homework. I'm doing my best. So often a lot of our maths is real world. We're in the car driving to swimming. What's 5 times 5? What's the time? My daughter loves the Met Service app, so we do a lot of decimal work through the Met Service app. So every morning she reads me the weather, she knows that she needs to tell me the precipitation, her hour rates and all of those bits and pieces. So she's learned to read decimals since she was a little chicken. Now, that's the stuff, if I made her sit down and do a worksheet with me, she is not the sort of child who would ever do a worksheet with me, okay? She needs to know the practicalities. I have taken her overseas and flown internationally. So she's learned to read 24-hour clocks and times and airport things. Math is everywhere. She knows that when we talk, I talk about, for example, the right angle. I talk about an acute angle. Some of your children I might have taught this. I talk about an obtuse angle because it's a bit overweight. And reflex because we're doing a bit of dance, so all of those bits and pieces. So it's bringing that language of maths into everyday life. So I think I learned about on a webinar recently, there are 1,300 pieces of vocabulary that go with mathematics. So in that, knowing that the biggest thing we can do as parents is expose our children to math in the real world. So that cooking, that building, that supermarket, all of those bits and pieces. But this little booklet here actually says, well, if I want to help my child in the car with their times tables, and they are in Year 2, in Year 2 they need to be working on recall, multiplication and division facts 1 times, 2 times, 5 times and 10 times. Okay? It tells me what I can do at home to really support and scaffold. Now your teachers, of course, are teaching your children all of these things and exposing them to them, because that's our curriculum. And we have to expose all children to these areas. Doesn't mean Michelle's retained it, because she might have been away with the flu, and so, that forgetting curve like we said, so that's that importance of constantly going back to review. So with my daughter, I haven't practiced her times tables with her in a while. We might do it once in a blue moon. She is really good at them, but because she's good at them, I don't stop making her practice. I make her circle back. And I still keep asking her those facts, because knowing 8 times 8 is 64 will help her with, she's got 0.8 times 0.8, and she's going to be able to do that transferable fact when she gets to that sort of equation. So through to when you're in Year 6, and of course I haven't got the glasses on, it is really around adding fractions with like or related denominators. So you've got to really it's your fractional thinking, it's your percentages. It's being able to understand the connection between fractions, decimals and percentages. It's being able to understand that actually there's 20% of this, and how much are you now paying for it. So that's the biggest thing you can do with your kids. Teach them about how to shop with sales. Huge. At the back, we've also got, and this is just number. This is the vocab for number on this page. If I'd given you the vocab for all of those strands, it would have been a much bigger book. And actually, we can only do what we can do. And if you're going to start somewhere, start with that foundation of number, base 10. Okay, so that was one thing. Hopefully those strategies Now, we started with this slide here of knowing, doing, understanding. It really comes back to if you know some stuff and you can do some things with it, then you're actually going to have greater success. Okay? I might not be good at everything, but I know I can use my calculator sometimes when I'm at the supermarket. I know that. That's a strategy as well. And I know how to do that. So therefore I'm going to have greater success. So I guess if you go away with anything from today, just go no, do, understand. No, do, understand. Because the more they know, the more they do, the more they understand. And the real world. So we haven't given year 7 and 8 in here, but if people want to call it all about year 7 and 8, we can totally do that. So this would be my charts, and I can't believe we've actually had 57 minutes past 6. To answer any questions to people in the room, those people on the live stream, thank you for attending, and sorry about the black screen to begin with. Technology was always fun. At the writing one, I forgot to turn off my, what was it, Claire? My restrictions on Facebook, because my child gets on my phone and it kicked me out after 15 minutes. So everything goes wrong generally when you're doing this. So any questions out there, or you can stay behind. I might cut the live stream anyway, if that's all right with everyone. Live streamers, thanks for coming. Oh, how do I